I don't know everything, but also this is stuff.
States.
States. I can start. I can start. I think I can probably do
that screen is mine.
I have a discussion now.
Okay.
So how many of you are here for the programming workshop? So hello everyone, welcome to the 6th programming workshop. Our topic for today is advanced code organization. So basically we're just going to go over some tips and tricks on how to make your code a little bit more efficient or cleaner and be easier to work with. So does anyone have any questions before we start on anything that we've covered so far? There is no there's no project for you to clone this time, but you can see the slides there on the Discord. So if you want to open those up and have a reference, then you can. Otherwise, we can just get started. So, our first topic is organizing code. So, we have a couple problems right now that you might have been facing or could hypothetically face while writing Unity code. So we can't set private variables from the editor. So if you have a private variable, it's going to be set, and you can't really change it outside of that script. That's kind of a problem because if you want a private variable but you want it to be set from the editor so that you can change it during testing, then you're kind of out of luck. Another problem is complex behaviors that you want your character controllers to have or enemies to have look really ugly because we have all these if-else blocks with nested if statements and all this really clunky stuff that kind of makes it really hard to read your code. And another problem is if you have a lot of the same kind of object, like say you have an enemy, but you want those enemies to have slightly different behavior or have a different function or something, then you have to kind of copy paste a lot of code. Say they each have the same speed and the same all these other variables, but you want them to have a different movement behavior, then you need to copy all of those variables every time you make a new enemy. So we have solutions to each of these in this workshop. So the first thing that we want to cover is serialization. So that's a really big, stupid word, so what is it? I have some links to the documentation if you want to read more on it, but basically the concept is serialized values are values that Unity stores in the editor somewhere and then reapplies to your script whenever it is reloaded. So by default, say you have a variable in your script and you set it to say 2. Then every time you reload that script, it's going to be set to 2, and you can't really change it anywhere else. What serialization does is you can set that elsewhere, say in the editor, to 3, and so it'll always be 3 despite in the code you setting it to 2 initially. You can also, this applies to basically every component that you set in the editor. So going here, each of our components has variables and values that we can set in the editor. In the actual code representation, these are set to a default value of mostly 0 or 1. And this default would probably be white. But in our editor, we can change these to something. And Unity saves these values, and then every time it initializes, after that initialization's done, it's reapplying all of the values that we want. And we can actually change those while the game is running from the editor and all this stuff. So that's kind of the upsides to serialization. And you can read more about it in these 2 links. They go pretty in depth on that concept. But basically, we've been using serialization in our scripts a little bit, when you make a public variable or a variable public and you set it in the editor, you're serializing that value or that variable, and it's going to use whatever you use in the editor for that variable. Anyone have any questions on that so far? Okay, so the first thing we want to do with serialization is we can have a tag, I don't really know what to call it, that we can set for variables that are private, but we want to be serialized. So that's just called SerializeField, and you surround it in square brackets. And so what this is going to do is we have a private variable, but if we put SerializeField in front of it, we can set it in the editor. And it's going to be serialized, and you can change it on the fly. You can change it, whatever. It's still going to be private, so the only thing that can change it is that script, but it has the added benefit of being serialized. So I can kind of demonstrate that right now. So we have our entity 1, and if we want to have, say, a private int, and we go back into the editor, then our entity 1, we can't see it in here because it's private. But if we put SerializeField above it, just before its declaration, then we reload it, and so now we have my int, and we can change it, and when Unity runs, then it's going to use this value instead of whatever value we set it in here. Does that kind of make sense? You can see the code again. I can zoom in a little bit. Maybe can't actually zoom in, but yeah. We also have a scripting reference link at the bottom of that if you want to learn more about that. The next thing we want to do, which is a little bit more advanced, is System.Serializable. So this makes, so there's a couple of types that Unity can serialize by default, and you can see them in the editor. Some types, like classes or structs and stuff, they're not going to be serialized by default, so you have to kind of set them to be serializable. So basically what this does is if you have any data structure, we're using a class here, and you set it to be serializable, then it's going to be able to kind of put that structure in your script, and that you can set all of the actual values inside of it inside of your script. I can go ahead and demo that now. If you aren't familiar with like the class terminology, don't worry, it's not super important, but basically it's a data structure that holds variables. So we can have a class, my class, make sure I'm declaring it correctly. These be public, make it public, and we can have a public int my int, and then public int, what is it? Yeah. My array of ints. So now, if we make this a System.Serializable, and also keep in mind that you don't need to put semicolons before this, because technically these can go before this public initialization, but we just put it on a line above it for readability. So don't put semicolons at the end of these tags. So now if you go into here and have Unity reload it,
Wait a minute. You have just declared a class, but you have not used it.
So now we need to have a instance of this class. So my class and instance. So now we can access it through the instance. Thank you, Wayne.
You forget to make that public.
And we make it SerializeField instead of public, just so we can kind of demonstrate that. So now we have this little instance, and we can kind of mess around with it. So we can set the array size to be 5 and set all the elements, 4, 5, 6, 3, 7, and all of that. And all of these are serialized, and it's not a public class or anything. Well, it is a public class, but it's not a public instance. Does that kind of make sense? Even if you like kind of don't understand how classes work. Yep.
When you create a class in a class, does it do anything? Does it make it a child or something at all, or no? Not in C#. So I'm declaring a class here inside of the class, and so you access that class from this instance, but it doesn't, when I make this class, it doesn't inherit anything. I would have to inherit this class from my entity 1 in order to inherit all of that. But just declaring it inside of this doesn't necessarily do anything like that. It's just you would create a class outside of this class by doing myEntity1 dot my class and new class or whatever. Does that make sense? Yeah.
Okay. Any other questions on that? Okay. So, the next topic is scriptable objects, which are a really, really cool method that is kind of similar to making a class, but it's a little different. So, a scriptable object is just kind of a data container that you can kind of reuse on multiple objects. So, what this is basically doing for us is if we have like 100 instances of like an entity, say we have 100 tilers in our game, and all of the tilers share a couple variables like the speed and maybe the initial health and stuff like that, then if you actually instantiate all of those, then you're going to have 100 copies of the same variable taking up space in memory. And that's pretty inefficient, especially when you have thousands of an instance in a scene, and you want to really save as much space as possible. So what this scriptable object does for us is it takes all of this shared data and puts it in a single container that each of these objects kind of reference. You can do a similar thing if you have one object that has some data and each of those objects get the data from that object, but this is just kind of a cleaner way to do it. So this is kind of how you do it. Your scriptable object is just a script, but you don't actually attach this script to an object yet. So first we just make a class or a script that instead of inheriting from monobehavior, it inherits from scriptable object. And we basically just declare all of the functions and all of the variables that we want to have. And you can serialize the variables, or you can make them, you can set them from the script or whatever you want. But basically you just have all the things that you want to share in a script. So I have a script right here, my scriptable object, and instead of this monobehavior, we just delete that and say scriptable object. So if you try to actually drag this onto an object, it's going to yell at you and say you have to be a type of mono behavior. So don't actually try to drag this onto anything. This isn't what you actually drag onto objects. So let's say I have a public int speed and a public int initial health. And you don't really want these in your script, so you just really want only what you want in your want to share. So now that you have that, the next thing to do is make a create asset menu tag. So what this is going to do is it's going to let you create an asset that is based on this scriptable object. So this is kind of a really advanced behavior, but basically we have our assets down here, and we have assets like this, white square and everything. And basically what we're doing with this scriptable object is we're describing a new kind of asset that we can make. And that asset is going to basically just store these variables. So if we, before this class declaration, put create asset menu, and we go into our scene, then if we just right click in these assets and go to create, then we have my scriptable object up here. Magic. So if we create one of those and just name it scriptable instance or something, whatever, and we can set these because they're serialized. And so how we actually use that in our scripts is let me skip over that for now. We declare a variable that's going to hold that data. So we have a public scriptable object and then the name of it. So in my entity, I'm going to have a new my scriptable object, and then I'm going to call it scriptable object. Scriptable. I'm just going to call it scriptable. No. So now, if we go into our entity, we can see that we have a little thing that is expecting a scriptable object, and the scriptable object is this asset that we just made. So if we drag this into here, then we now have access to all of the data in here. So we can access that with, say we go down here and just start, and we say debug.log the scriptable object dot, and then, no, get out of your windows. And we want to access, say, the speed. So we would do scriptable dot speed. So now, if we run this, because this is going to run in start, and go to our console, it prints 59. And inside of our scriptable object asset, we can see that our speed is 59. And I can't really demonstrate this right now, but you can actually change this right now, and it's going to update all of the things that kind of are using this, all of our entities, and it's going to affect all of them at once because it's just one thing in one place in memory. However, unlike most things, if you change this value inside of play mode, it's going to stay set. So if I get out of play mode, then speed is going to be what I set it to in play mode. That is very different from most behavior in Unity, so just kind of keep that in mind. If you're doing like some playtesting and you modify one of those scriptable objects, then it's going to stay changed it's going to persist. So yeah, that's just kind of that. Does anyone have any questions on all of that? That's like a lot of information. Yeah.
Would you recommend with scriptable objects that we find a way to reinitialize a value every time we run it, so that way we don't face that problem of it being modified every time?
Yeah. So if you don't want these to be you know, changed from the editor while you're playing, you can just like make these non-serialized. So you can say int speed equals 10, and I know it's 10, I'm not going to change that ever. Then I think you can still access that if it's not public, right?
I forget, because I usually make it public, and I
Let's
will
see.
not, like, if this is something I want to edit, I will not make it a scriptable object.
Oh, no, it has to be public. So I will get back to you on that. I'm not sure of a way to do that. I would say just kind of be mindful of when you're changing that. I believe you can also change these values in your scripts. So I will look up the best practice on how to deal with that.
If you change these variables in script, they will also like never change back, because
Yeah.
Unity handles scriptable object in a different way.
Yeah. So if you change these values in a script, then they're going to persist throughout everything. Does that make sense? Any other questions on how this works?
Can I say something really quickly?
Yes.
Great. Can I do like an announcement?
Yes, go ahead.
Great. Thank you for the floor. How many of you guys do I know, or I've taught before? None of you? Yeah. Okay. My name is Kat Brewster. I'm a PhD student. I work upstairs. And I wanted to come down, and I didn't know that you guys were having a meeting tonight. That's so cool. Are you guys every Thursday night?
Well, this is
Is today Thursday? Today's Wednesday.
Wednesday. This is a workshop. Our meetings are every Tuesday in HSLH.
Radical. Cool. Well, I'm glad that I stumbled upon all of you. I'm putting on an arcade. It's going to be on December 1st upstairs in DBH in 6011. And I've invited like a bunch of game devs from around the world to kind of show kind of independent, broken, experimental, weird things that they have in their back catalog that they want to show off. I think it would be super cool to have like some VGDC presence there, kind of outside of our open call, because I want to be able to support kind of you guys and the work that you're doing, and make sure that there's kind of a space to be like, also there's game dev happening like here at UCI. So if you have any games that like you have made at a point in time when you're like, I would love for people to play this, or I really want to show this off, please email me, let me know. The open call technically ends on Friday, but because you guys are like right downstairs sometimes, and I'm right upstairs all the time, I can talk with you and we can figure out a space to be able to put your game in the show, and it can be alongside people who are showing games from Berlin, Iceland, the UK, New York, LA. And that would be really, really cool, and I want people to come and see the games. I have some like preliminary posters here for the arcade, if you're interested. Oh, is that just like a thumbs up, like generally? Great, awesome. I'll write my email address on it, and I'll post it here. Can I post this here?
Sure.
I'm asking you, like you own this room.
Yeah, sure.
Okay, cool. Does anyone have any questions, comments, concerns, or like thoughts about what an you know what an arcade is? You're not idiots. Yeah? Cool, cool. That's a good break from learning about scriptable objects, right? All right. Thank you so much. You may resume your workshop. Oh, an applause. Wow, thank you. All right, don't applaud me. That's weird. Back to Unity.
So, back to Unity. Also, another thing is scriptable objects can have functions. So if you just kind of want to have a function that kind of manipulates this, so like int double speed, you can kind of access this from any object that you have, and we can do scriptable.double speed. I believe it needs to be public, so I'm going to change that. So now if we run that, it'll print out double the speed, which is actually not 110, but it actually is kind of 110, isn't it? Because I set it here. Yeah, that works. All right. Any other questions on scriptable objects? Okay. And moving on. So, another really cool data structure is enums. So, enums are basically just like names that you can use in your scripts. So, typically, if you wanted to store information about, like, say, a player's state, like is jumping or is doing something else, you would use like booleans or integers. So, say if you wanted like a list of states, like is either jumping or is on the ground or is falling or something, you would use like an integer or something. The problem with those is that they don't always really represent exactly what you want, and when you're reading the code, it's just like, if my state is 0, then do this. It doesn't really say much about the actual state. So the kind of solution to this is to use an enum. So basically, an enum is just like a constant representing a value between 0 and unbounded infinity. But basically, they're integers that you can access with real names. So in this example, we have an enum that is fruit, it's like apple, banana, strawberry. You can also have enums that aren't named, so they would just be, you know, apple, banana, strawberry. And you can access these with just like fruit.apple or something like that. So if we wanted to use this in our script, we would have an enum, and then we just specify, like, say, we'll do state jumping, state falling, state on ground. But do you have to name enums in C#?
I always do, so I don't know what will happen if you don't put a name.
I'm used to unnamed. Okay, I'm gonna name it state. So we have an enum named state. And so what we can do is we can have a variable that holds one of these. So we have a state my state, and we set it to, by default, be state.state falling. So now we can actually do some code based on this state. So like if my state is equivalent to state.state falling, then we can say we want to our transform keyboard. And we just say 0, -1, 0. It's not 0. So the real power in enums is when you're equating it to something. So if we weren't using enums here, we would just have an int for our state, and it would be between like 0, 1, or 2 or something. And then this if statement would be like, if my state is 1, and that doesn't really, say a whole lot about your state. But if we have all of these names, and then we access it with, no, get out of here, state.state falling, we know immediately that this code's going to run when we're falling. And so you don't really care about what the actual value of that is. You just care that it's the state falling. This would probably actually be represented by a 1. This would be represented by a 0, and this would be 2, and so on. But we don't really care about what those numbers really are. Most of the time, you can if you want, but we don't. And so if we run this code, our state is falling, so it's just going to fall off the screen. And delete that code. Does anyone have any questions about that? How we would use enums? Okay. So I mentioned that if we wanted to have really complex behavior, like say you have a character controller and you want different behavior based on whether you're on the ground or in the air, or you don't have player movement. Say if you're like in a menu, you don't want your player to be able to move. So if you were to implement that normally, you'd have all of these different if-else blocks. So like you'd be going through and like if the player can jump, then do this. But like above that, you would have if the player can actually move, then do this other thing, and so on and so forth. And that gets pretty ugly pretty quickly, and it like takes a big, huge chunk of your update. So there is a more elegant solution if you're using a kind of state-based thing, and that is the switch statement, or the case and switch. So in this example, I have an enum called state. I'm assuming that this is unnamed. I kind of screwed up on that. But basically, we have our state variable, and this holds an enum that describes something about our state. And so in the case that it's state on ground, then we run a function that's on ground. Otherwise, if it's jumping, then we run a jumping function. And then the default is the idle. And so this is kind of a lot cleaner than the functional equivalent is just to say if state equals on ground, then do this. Else if state equals jumping, do this. Else idle. And you can do that, but this gets a little bit easier to manage. I'm not going to do an example because it's kind of on the screen. But this makes your update a lot easier to kind of parse. And you can have all of these functions elsewhere in your program that you want to say, okay, I just want to modify the jumping statement or the jumping function. And you don't have to look through all of your update to get there. You know that your update is just doing this case statement, and then everywhere else in your code just represents one of these states. Does that kind of make sense? This is just like one way to organize a player controller, but it's kind of an organized way. So I can demonstrate the case and switch here. So case, no, switch. So we want to switch over my state. And in our state block, we have the case of state jumping, state.c jumping. And then we want to, I'm just gonna break here. We have another case of state dot state falling, and this is where we would kind of have our other function, but I'm just gonna break because I don't want to implement that, and then our default, which is just the default keyword. So inside of all of these, I would have, is that yelling at me?
Maybe instead of case default, it should just be default.
Oh, right, right. So the default keyword and then break. So basically what this is doing is it's going through my state, and then I would have all of the either all of the behavior inside of these cases, or I would have a function call somewhere else in my script. Does that kind of make sense? Okay. So we mentioned in last workshop the prefabs and how to use kind of prefabs, but we didn't really mention or give an example of how to actually use them in a script. So I'm going to do a little demonstration here. So we have our entity 1, and I'm just going to make a prefab of it. And so we have this entity, and say we want a empty game object to spawn these entities. So then we would have a script for that object. So let's say we want it to be a entity spawner. So in our entity spawner script, first we need to actually have a variable that holds our prefab. So it's just the game object type, so public game object entity to spawn, and then in our editor we can see if we drag the script, we have a game object that we can put here. So we can drag this game object, which is our prefab, into here, and so now we actually have this entity that we can manipulate. So if we wanted to spawn this, say, every second, we would have a time, and then set our time 0, and so we would just have time plus equals time dot delta time. So this is just kind of counting up from 0, and we can use that to say if time zero, so that's going to be every second. If I'm doing that math incorrectly, let me know. Then we want to use this function, which is GameObject.Instantiate. So this is basically, I believe we explained this last time, but this is basically going to be spawning the object just as you would in the editor, just while the game is running. So we have to give the game object that you want to spawn, we need to give the position that it's going to be, the rotation. Typically, you just kind of want it to be normal rotation. You can also give it a game object to be the parent, but that if you don't give it anything, that it's just going to be in the hierarchy without a parent. So let's just say instantiate. We give it our entity to spawn. Say vector 3 0 0 0, and then Ternnian identity. And so that's just going to be basically no rotation. Where are you? Oh, I have to have a new vector 3. So now when we have our game object running, we should actually probably have our entity be moving. What did I do now? Entity is spawn.
I don't know how does the mode works for float. So can we use the traditional way to just say if it's bigger than 1?
Yeah,
And we
I was
reset
trying to be
this
fancy,
the-
but that's just you bigger than 1.
Because the like mode signal modifier. I
Yeah.
don't know how to say that. Like it works differently in different language.
Yeah. There we go. So, as we can see, every second it's just spawning a new entity and they're just going down. So that's kind of how you would do that. You would typically have this behavior if you're like spawning enemies in a game and you like want to spawn enemies just off screen, then you would be spawning them, wherever. And so also you want to be able to delete these, because if you have too many objects, then they're going to be cluttered and your game is going to slow down. So now we want to destroy them. So first we need to actually have this object that we spawn in a variable so that we can keep track of it. So we have GameObject spawned entity, and so we would actually set this. First, let's actually copy this here. So we would say our spawned entity is the entity that we spawn. So instead of just calling this function, you would have it, you would set some variable to it. And so inside of our function, we can say spawn destroy capital, and then our spawned entity. So once that's destroyed, then we can set a new spawned entity. To that, and then restart the cycle. So now it's we're only going to have one entity in the game at a time, because every time we want to spawn a new one, we're deleting the old one. Does that make sense? Yep.
So in the old instance, we just created a infinite amount, and they were all falling beyond the screen.
Yeah. So if we were to zoom out, they would have just been like a line that were just continually going down, and you could see them in this hierarchy here. So we can see that this entity is getting deleted and then respawned. In the old version, we had like a list of entities that were just being created. And then when we unpause, all the entities that we spawned during the play, or the game, will be deleted. Make sense? Okay. So we have just a little bit of time. So what I want y'all to do right now is, if y'all are working on like a game, then I want you to think of something that you can take from this workshop and apply it to your game. Does that make sense? And you can talk to us and kind of ask questions about what you want to implement, so on. Yeah.
Wait a minute, Tyler, go back to the last slide. So for the destroy function, you can also put the second parameter, which is the time. And if you have a time here, it will destroy, like it will not destroy the object immediately, but will destroy it after an amount of time. It can be useful when you, like for example, I instantiate this object, and I know it will like go beyond the screen in 5 minutes, so I will say destroy it after 5 minutes, 5 seconds.
Yeah, and so that just takes a float as the second parameter, which is optional. So yeah, these slides are up in the programming channel. And if you want me to demonstrate something or go a little bit more in depth on anything, just let me know. And yeah.
And this was recorded to test, right? This was recorded too, right?
Yeah. Yeah. I should actually put it's up the stream, but yeah, it's on Twitch.